Good morning, everyone. Thanks for having us, Leap and PTC and all the rest. I'm Zadnik. I'm the Aerostructures Lead of Monash High Powered Rocketry. We're a student team based here at Monash, founded in 2018, and now consists of over 80 members from all specialisations of engineering, design, IT, commerce and arts. And each member within the team is working towards our vision to become well-renowned contributors to the development of rocketry and the space industry in Australia at a technical level. And our current activities include internal research and development projects alongside entries into both domestic and international competitions. And so this includes the Australian Universities Rocketry Competition along with Spaceport America Cup. And I'd like to touch on a couple of these activities and recap how Creo and Windshield have made them possible. So the team is really excited to be working on an internal hybrid motor, Solaris. And on the screen here you can see a render of that in Creo and alongside its final production form. And handling the oxidizer within this system is quite a complex process, requiring a huge amount of valves and piping. And Creo enabled us to import all these CAD parts into assemblies from the CAD produced by manufacturers and assemble them in the virtual world, making sure that the design was robust. And we were lucky enough to perform cold gas testing a couple of weeks ago now, which was the first step of physical testing for this motor and proved that with the software we had at our disposal, we were able to create a working design. The other big project I'd like to share about, which I'm sure you didn't miss coming in at the doorway there, was Project Aether, our recent entry into Spaceport America Cup in New Mexico. And the competition saw the team launch internationally for the first time and bring home some results we're incredibly proud of. We achieved an apogee of 28,439 foot above ground level, which represented a prediction of apogee within 1.5% by the team. We achieved second place in the Charles Hoult Award for modelling and simulation based on our modelling of small design changes with a disproportionate effect on trajectory. And so the development of Project Aether started with an open rocket concept, and this is an open soft tool which is great for quickly estimating the parameters of rocket design. But as you can see at the top of the slide there, the design tools are severely limited. And so Lead provides us with the tools to take our initial concepts, sketches and designs and turn them into a physical product. Creo's toolkit allows us to create both simple geometry and complex geometry. The interface is really easy to use and super handy when we have such a big team of people and people coming in with various backgrounds of CAD ability. And so it makes it easy for everyone to pick up and contribute. Components like cylindrical airframe components can be completed in literally 3 clicks, while really sensitive components like our nose cone and transition require parametric designs which can revolve and model effectively. Our designs really tend to be limited by our own imaginations and manufacturing capabilities rather than what we can produce in CAD. And one of the features we're most grateful for as a team is the seamless integration of product lifecycle management in the form of Windshield. We've had Windshield for a couple of years now and allows us to catalogue all of our parts, which there's a great deal of, and we can work together to neatly organise files under our own cataloguing system and access any component we need across the entire rocket to discuss and understand how it interacts with the overall system, as you can see at that top level assembly there. A particular instance of this is the scientific payload for Project Aether, which is a thermochromic paint investigation focusing on skin friction. And the payload itself is defined by a 3U sat form, which dimensionally represents a 10 by 10 by 30 centimetre cuboid. And we were able to work around this dimension as an Aerostructures team, all the while Payload was continuing to develop their experiment. And as the design came to fruition, we were able to see where the interfaces between the two systems were and work to integrate them together. Creo also allows us to produce technical drawings in the AS 1100 standard. These are crucial both to send off to suppliers and manufacturers, but also as a requirement for our technical reports in competitions. This year we produced over 60 technical drawings for our technical report, and without being able to delegate those across Windshield and complete them within Creo, there's almost no way we would have been able to put together for the competition. We springboarded from Creo into its partnering software in Ansys, and we're able to use those parts seamlessly to perform FSI on our airframe, checking several failure modes which can occur during launch. We can look at our Creo model of the bulkhead and use topology optimization to minimize mass and ensure an appropriate factor of safety with it. We can also use the completed Creo model and take all of their mass, moment of inertia, and all those information and put that into our simulation software and partner it with our CFD. And all of that comes together into how we model our rocket's trajectory, and the precision of our modelling and the results in this year's competition, speak for themselves. 4, 3, 2, 1. Good job. So that was our entrance into Spaceport America Cup this year, and this has just been a really quick insight to the toolkit that Creo and Windshield have given us to complete that, and we're really looking forward to seeing what Creo 9 can add to our endeavours. Look forward to having a chat with you all in the break. Please feel free to have a chat to myself or the other team members here today. So thanks again for having us.